Welcome back to our series on data description. In our previous part, we described what is data, the importance of data description, and the difference between data, information, and knowledge. In this part, we are going to discuss different forms of classifying data depending on some of its characteristics. Let's have a look now of different ways of classifying data or categorizing data. Here in this picture, I am showing you 6 different ways of classifying data. You can search the literature and find other ways different from this one, but these are 6 very useful ways of categorizing. The first way that we are going to discuss is to categorize data based on its structure. In this sense, data can be structured, semi-structured, or unstructured. In terms of the nature of the data, it can be quantitative or qualitative data. In terms of the type, it can be either numerical or categorical. Concerning its time variability, the data can be invariant or static, or it can be time variant or time varying or dynamic. In relation to the dimensionality of the data, it can be unidimensional or multidimensional. And finally, in terms of ownership, the data can be public and private. Let's have a deeper look into each one of these categories. The first way to characterize data that we are going to discuss is based on its structure. In this sense, data can be structured, semi-structured, or unstructured. Structured data requires a data model, which is a way of organizing, accessing, and processing the data. And structured data are usually presented in tables or spreadsheets because tables and spreadsheets allow us to organize the data into, for example, objects in the rows and variables in the columns. This is the most standard way of organizing data, which is based on a specific structure. And structured data do not need any additional information for us to understand or to access or to process the data. When we talk about semi-structured data, we are talking about a data that does not have a data model in the sense that we don't have one fixed way of accessing the data that we have available. But in most cases, we do have additional information about the data, for example, tags or markers. Examples of this data are emails in which we have the subject line, we have some basic information about the sender, the receiver, the time it was sent, and all this extra information are called here metadata. And examples we also have XML files, we have web pages. In the case of XML files, for example, we have tags that have specific meanings that imply one specific type of data, and this form the semi-structured data. And finally, when we talk about the unstructured data, we are talking about a data that does not have a data model and also does not have metadata. Examples: photos, images, sound, text. When we look, for example, at these pictures that I brought you here, we can see here a computer code with different colors. We can only see part of it, but each of these colors have one specific meaning. Some of them are tags, others are markers, but they play one specific role in the code. This is a typical example of a semi-structured data because we have some metadata there that helps us to understand and to access this data. Here we have someone writing a text, and this text is completely free text, and it is thus an unstructured data set. And then if we look in this picture here, we have a table, a spreadsheet with some columns and some rows. This is a typical example of a structured data set. Now we can discuss the classification of data based on its nature. In this sense, data can be classified either as quantitative or qualitative data. Quantitative data are numerical data that, as numbers, you can perform different type of statistical measures with them, like we can calculate the average, we can calculate standard deviation, we can calculate the variation, so we can calculate different type of statistical measures over this numerical data. They're also structured in the sense that we can create a data model to organize, to access, and to process this data. They are objective data in the sense that they have one specific meaning, which is represented by their values, and they are also measurable. In contrast, when we look at qualitative data, they are categorical in the sense that they express different categories. They are non-statistical because we can calculate some basic statistical measures from this data. They are going to be either semi or unstructured. They're subjective in the sense that I can have different interpretations of this data or variables. For example, we can have a variable that is low, medium, and high, but low, medium, and high can have different meanings for different people. So if this is not well defined in my problem, the interpretation that I do out of this data is subjective. And that's what we mean when we say that qualitative data are subjective data. And they are also understandable in the sense that we can easily understand its meaning, even if the interpretation is subjective. We can still understand what is something low, what is something medium, what is something high. Let's say, for instance, that we are talking about temperature, right? Each and any one of us have its own perspective of what's a low temperature, what's medium temperature, and what's a high temperature. So that's the classification of data based on its nature. And to exemplify, here we have a data set with quantitative and qualitative variables. We have a number of patients here. There are 5 patients. They have different variables like BIRABS, age, shape, margin, density, and severity, independently of the meaning of each of these variables, which we are going to discuss further in this series. What I want to stress here is that we have in the same data set, we have some variables that are numeric, thus they are quantitative, and we also have some variables that are qualitative or nominal in this case. Something that is also worth mentioning about this data set is that it has some missing values represented here by the question marks. When we talk about numerical data, they can be either discrete or continuous. And by discrete here, I mean countable data. For example, we have the years, we have the age, we have the number of votes, we have the number of children that someone has, and so on and so forth. So discrete data are countable data. By contrast, continuous data are data that are uncountable. For example, we have the height, and here we can talk about height based on feet and inches or based on meters. And in this case, we can have, for example, 1 meter and 72 centimeters. So this is a continuous scale or a continuous value that I am using to describe the variable height. I can do the same thing with other variables like the weight, like the grades in a certain exam. And we can subdivide the continuous variables into interval variables or ratio variables. The interval variables are those that can be measured using one specific scale. For example, temperature can be measured in degrees Celsius or in degrees Fahrenheit. The IQ scores can be measured in one specific scale. Then we have the ratio data that are those that have well-defined 0 point in this scale. For example, we have the grades in an exam that can go from 0 to 10 or 0 to 5, depending on the scale that you choose, on the range that you choose. We can also exemplify here with the market share that span the interval from 0% to 100% of market share. These are the main types of numerical data that we have. We also have the categorical variables that can be binary, nominal, or ordinal. The binary variables are the ones that can only assume 2 values. The most common ones are 0 and 1, but it could also be true or false. It could also be -1 plus 1, or different 2 categories that you want to use. We also have the nominal variables, and these are those that have distinct symbols or labels describing them. For example, when we think about marital status, it could be single, married, divorced, separated, widowed, right? So we have these labels or categories that are names describing these nominal variables. And finally, we have the ordinal variables that are those that have a specific order of categories, such as high, medium, low, or very slow, fast, very fast. The important thing here is that there is an order, and this means that high is closer to medium than it is to low. And this is the reason why these variables are called ordinal variables. Let's have a look at the three other ways of categorizing variables. First one is based on the time variability. We can have data that do not vary over time, and we can have data that vary over time. One specific type of data that vary over time, we call it time series. And the time series, for example, when we think about the weather, or more specifically the temperature has a value for each instant of time, so it varies over time. And this is a typical example of a time varying variable, right? Another example is the value of the stocks. While the stock market is open, the value of the stocks are varying. So these are also time varying variables. More specifically, they are time series. If we have any type of stock that whose stock market never closes, like crypto, for example, cryptocurrencies, which you can negotiate at any time, any day of the week. So this is a time varying or a time series that has values continuously over time. But we also have variables whose values do not vary over time. Let's suppose that we are measuring the weight, the color, and the shape of a stone. This stone doesn't have any variation in its weight, in its color, or in its shape over time. So this is an example of a static variable. Talking about the dimensionality, this corresponds to the number of variables that we have describing one specific data, and it can be unidimensional, which means that we have a single variable describing that object, or it can be multidimensional, meaning that we have multiple variables describing that specific object. To illustrate that, let's take an example from this table here. We have 5 patients from patient 0 to patient 4. Each of these patients are described by the 6 variables: PIRADS, age, shape, margin, density, and severity. This is an example of a multidimensional data set. If I had a single variable describing this patient, it could be any one of these variables. Then this would be a unidimensional data set. Finally, let's discuss the ownership of the data. We can classify data in terms of ownership, basically on public data or private data. Private data is that data that only you have, in the sense that you collect this data. So let's say that you work in a marketing company and you have, for example, data about your customers, data about all the campaigns that you've made. So these are your data. They are private data. But at the same time, you can have public data, data available on the web or on other places, related with your customers, related with the campaigns that you've made. So these are public data that are of interest of you because they may help you improve your performance. They may enrich the data that you have to do the analysis and everything that you need to do in your company, right? So that's a way to categorize data in terms of ownership. Thanks for watching and see you in our next video of this series.